Based on some historical trends, the diagnostic center expects the potential daily arrivals of the 3 patient types as follows. They will on an average receive 100 patients of type 1, 200 patients of type 2 and 220 patients of type 3. So, given this information, so now we have almost all the information with us. So, given this information, let us analyze the process and make estimates of capacity in order to develop some insights into the process. So, now that we have the process flow in place, let us now do the calculations and see how it affects the capacity. So, let us look at this table. You find there are already some data as part of the table because these are part of the input data. For instance, the process time is known already, the number of resources available is also known, the demand at the station at the first point is also known. So, we already have this data. Let us develop further and try to estimate the capacity. The first thing that we will do is we will convert the process time into capacity per hour per available resource as we did in the earlier examples. So, 20 minutes would actually mean 3 per hour as far as preliminary investigation is concerned. Preliminary investigation for patient 2 is 15 minutes, therefore 4 per hour. Preliminary investigation for patient 3 is 10, so we will have 6. Coronary unit takes 30 minutes, so we can process 2 per hour. Radiology department 10 minutes, so 6 per hour. Gynecology department is 20, so we will be able to process 3 per hour, and final review is 10 minutes, which translates into 6 per hour. This diagnostic center works for 8 hours. So, we can now calculate what is the potential output possible at each of these workstations. Let us take preliminary investigation 1 for patient type 1. If there is one resource, 3 patients can be processed per hour. There are 5 resources, therefore, we can process 15 per hour, and because there are 8 hours per day, so 15 into 8 makes it 120. That is how you get this number 120. Similarly, if you do it for the next, 6 into 4 is 24, 24 times 8 is 192, so that is the capacity possible. And in the third step, 5 into 6 is 30, 30 times 8 is 240. Coronary unit is 5 into 2, 10 times 8 hours, that makes it 80. Radiology department is 6 into 6, 36 and multiplied by 8, which makes it 288. And gynecology department 3 per hour, there are 8 resources, which makes it 24. Again multiplied by 8, you get 192. And finally, you have the final review, 6 into 10 is 60. Again multiplied by 8 hours, you get 480. So, now we have found the station output with respect to each station. Let us find out what is the actual output. Remember, the demand at this station is 100 and it can produce 120. So, the actual output will be the minimum of the 2, so which turns out to be 100. In the second case, the minimum of 192 and 200 happens to be 192. Therefore, the actual output will be 192. In the third, the minimum of these two happens to be 220. Now, let us come to the fourth, coronary unit. Now, if you may recall, type 1 patient directly goes to the coronary unit. So, the output from this will have to come here, which adds up to 100. Also remember that 20% of type 2 patient also is supposed to come to the coronary unit. So, we need to take 20% of this. So, 20% of 19.2 makes it 38.4. So, totally it is going to be 138.4. Now, the demand is 138.4, the output is 80. So, the actual output cannot be more than 80, which is the minimum of the 2. Radiology department, type 2 patients, 80% of them come to radiology department. So, type 2 patients 80% will come here. So, 80% of 192 makes it 153.6 plus type 1 patient, all of them will come, and because they go through that process from the coronary unit, they go to the coronary unit. So, the output of the coronary unit is 80. So, you have to add that because this will also come to the next stage. So, that makes it 233.6 and the minimum of these two happens to be 233.6. So, that is going to be the potential output from here given all these constraints. Now, gynecology department, type 3 patients come there. So, there are 220 of them, all of them can come here. The minimum of these two is 192, therefore, that is going to be the output. And in the last stage, all patients from here will come and all patients from here will also come, which makes it 233.6 and 192, which makes it 425.6 if you add these two, and the minimum of these two happens to be 425.6. So, you see here all these calculations that we just performed. First and the most important observation I am sure you would all appreciate is, even though this diagnostic center can receive 520 patients potentially, the calculations show to us that it cannot handle more than 425.6 patients every day, because that is the output, actual output at the last stage as we saw in this table just now. Some more observations we can make. Coronary unit seems to be the bottleneck in the system, because as you notice here, the type 1 patient also passes through coronary unit, type 2 patient also passes through the coronary unit, and the output of the coronary unit is just 80, which is constrained by the resources available. So, this is going to affect the output eventually. Therefore, some capacity additions in coronary unit 1 will become inevitable if we want to increase the number of type 1 and type 2 patients going through the diagnostic center. So, that observation we can make. Let us look at the gynecology department now, which is patient type 3. And what we see is the preliminary investigation is not the bottleneck, it is actually the gynecology department. That constrains the flow of type 3 patients in the system, and therefore, that is the bottleneck for that type of patients who visit the diagnostic center.